Welcome. So I guess just to get started, we want to tell you a little bit about ourselves and why we're going to give this talk. So I started last summer at Puppet Labs as an intern in June, 1 month after I had finished my college degree. I had graduated with a degree in linguistics. I had taken about 3 computer science classes, and I had studied, or I had dabbled a little bit with Python. But I had no experience with Ruby, and I only sort of understood what Puppet actually did. But despite that, within my first week of joining the Factor team, I submitted a pull request that was accepted. So basically, we feel like, if I can do that, then anyone here can contribute to Puppet.
Yeah, so I was kind of in the same boat as Ruth when I started. I just finished my sophomore year studying electrical engineering. I think I'd taken 2 programming classes. I wasn't familiar with system administration or Puppet, and I came in, and within my first week, I think I submitted 2 or 3 pull requests to Factor. So the reason we really wanted to give this talk is we know that a lot of people want to give back to the community, and we think that regardless of your background or skill level, that's like a real possibility. So what we really want you to take away from the talk today are skills, tools, and confidence. So what we mean by that are today we're going to walk you through the contribution process and help you develop some of the skills you need to contribute. We know that 40 minutes is not a very long time, so what we also want to give you are some tools and resources for self-learning and getting started on your own. And we really want you to feel confident by the time you leave. So we know that the contribution process can be mysterious to a lot of people and a little bit scary. So we're hoping that when you leave, you're comfortable with it and you're ready to get started. So why should you contribute to the community? It's a decent chunk of your time. You probably should have a good reason to do it. So the first thing is that it's really valuable for you. You're improving the software that you're using. And on top of that, it feels really good to give back to the community. It's exciting to see comments on your pull requests and have people appreciate your work. It's valuable for us, obviously, because we're making the software too. And we really like it when we can borrow skills and expertise and knowledge from the community that we may not personally have. And of course, it's valuable for the whole community. So it's a good chance for you to give back to everyone who's working together to make Puppet into a great product. And people will really appreciate you for your contributions.
And so it's great if you can contribute code, but maybe you don't have the time. And so as I think Dawn talked about in the last talk, and I think Lee's going to talk about this later, there's a lot of non-code ways that you can contribute to the community, from docs to the users groups, the Google groups, so Puppet users and Puppet dev, submitting bug reports or feature reports in our issue tracking system, submitting answers to questions on ask.puppetlabs.com, contributing to armatures in our armatures process, participating in IRC, contributing modules to the Forge. These are all awesome ways that you can contribute to the community without actually having to dive into the code and deal with all of that. And so these are, if you do want to contribute code, some of our projects. Puppet is the most obvious one, Factor, Hiera, PuppetDB, all of our modules that we have on GitHub. So all of these can be found on github.com/puppetlabs, and you can look at the code there and clone it and start working.
So Ruth and I had the opportunity to give a talk pretty similar to this one last year, and so just in making these slides, we were able to see a lot of the ways in which our process has gotten so much better than it was. Over the last year, we kind of did an overhaul about how we deal with community contributions. So as opposed to hoping that someone looked at pull requests and having it kind of be someone's job, we now have a dedicated team of people, and it's their sole purpose not to switch context and to constantly be looking at contributions from the community. We've also automated our workflow, and if you'd like to learn more about that, you should check out Jeff McCune's talk this afternoon. We've cut the response time at least in half. It used to take sometimes weeks before we would look at your contribution, and now it's usually a couple days. And we've also made it much easier to get one-on-one help if you're struggling with writing tests or something's not clear to you. It's really easy to jump on IRC, and one of us will help you out. We've also simplified the whole process. So I don't know if anyone's familiar with the branching system we were using. We had like 100 different branches that you may or may not target. It was very confusing. So now we have stable and master. 95% of the time you're going to target master, so that's pretty clear. We've gotten a little bit less nitpicky about things like naming conventions, commit messages, branch names, just to try to make it easier for you guys. We've improved the documentation, and since Don Foster joined as our community lead, we've way improved the CLA. So it's no longer on Redmine. It's very clear whether or not you sign the CLA. There will be a comment on your pull request saying whether or not you have. And additionally, we've introduced the trivial patch exemption. So if you're just updating a regex and changing one line of code, you don't even have to sign the CLA for us to accept your contribution. So what we really want to focus on today is the general workflow from figuring out what to work on to actually getting your code merged into our code base. We're going to talk about Redmine, which is our ticketing system. So how to either find an issue or create one. We're going to talk about how to get the code down from GitHub so that you can start working. We're going to focus less on writing code because even if we had an hour-and-a-half session, there's no way we could teach you guys Ruby and everything you need to know to do that. But we are going to give you some resources for self-learning. We're going to talk a lot about testing code because that's something that contributors struggle with, and about signing the CLA, and then finally when you submit your code and the kind of response you can expect from us afterwards.
So to start with, maybe you've found a bug in Puppet, maybe you've looked at the Puppet code and seen a feature that you want to add. No matter what you want to do, you're always going to start with Redmine, which is our issue tracker. It's located at projects.puppetlabs.com. You might be familiar with it from submitting bug reports. GitHub is great for making comments on code, but it's kind of horrible as a place to actually have discussions about bugs or features. So we want to make sure that any non-trivial code changes have issues in our issue tracker that we can refer to, that we can have discussion on there. So we want to make sure that you always have a ticket associated to whatever you're working on. It should be noted that at some point in the future, in the next few months, I think we're planning on switching to Jira for our issue tracker. At that point, we'll be talking with the community about what the plan is as far as dealing with existing tickets. As far as I know right now, we'll be making Redmine read-only, but have the ability to migrate over any open tickets to Jira. But obviously, we'll have lots more information when that actually happens. So if you've used Redmine before, you might know it's kind of horrible to actually try the search functionality in it. Definitely use Google search and specify site projects.puppetlabs.com. Otherwise, you have no hope of ever figuring out what's going on. But creating an issue, it's really important that you don't just say, there's a bug here, or this is broken, or I want to see this feature. It's much more helpful if you can tell us about what operating system you're running on, what version of Ruby, what version of Puppet or Factor or whatever, as well as tell us about why you want to see this feature, or what is actually happening when you have this bug, what error messaging is produced, how can we reproduce it. So if you don't have time to go and work on it, someone else can pick it up, or someone else can come across it and say, oh, this is the same exact issue I'm having. So it's really helpful for us if you can actually write decent issues in Redmine.
So now that you figured out what you're going to work on, it's time to get the codes to start working. So if you're not familiar with Git, it's the version control that we use at Puppet, and everything is hosted on GitHub. So the very first thing you're going to have to do is go to Puppet Labs and fork the repository of the project you want to work on. This basically means that you're saying, OK, I'm ready to work on this thing. Can I please have my own copy of this source code that I can work on independently of the code that other people are using? So once you fork your repository, you have to clone it locally by doing git clone the repository URL. This is basically saying, OK, I have my copy. Now I need to move my copy locally so that I can actually start working on it. And the next level of granularity is to create a topic branch for the issue that you're working on. So this allows you to isolate the specific bug or feature that you're ready to work on. It makes it easier to, if you decide you want to abandon that, it's just off in its own branch. You don't have to worry about it. And it helps keep things organized. It also makes it easier to submit pull requests. So we have a naming convention for branches. It's generally ticket, the branch that you're going to be targeting, the issue number, and then a short description of what you want to do. But again, we've gotten a little bit less picky about things like branch naming conventions. So if you don't get it quite right, don't worry. So most of our code is run with Ruby, except for PuppetDB, which is Clojure. I don't know how that works. Go talk to Nick Lewis or Deepak or someone. Functional programming.
So all of our stuff works with both Ruby 1.8.7 and Ruby 1.9.3. And we make, I think right now, a best effort attempt to support Ruby 2.0.0. We run tests against it, but don't officially support it yet. So it's important to note that you should be testing and running your code against multiple Ruby versions. You can use something like RBN for RVM to do that. We also have gem dependencies for development and testing. And we recommend using Bundler, which allows you to kind of contain the dependencies of a Ruby application. So you can just do a bundle install and get all of the gems that are needed with the right dependencies. This is especially really important for tests because if you try running some of our Rspec unit tests with the wrong version of Rspec or Mocha, a lot of them will just completely fail. If that ever happens, check your versions of these gems. But that's why we do recommend using Bundler for this. It just helps that you don't have to worry. You just do a bundle install, and everything's good. This is what the gem file looks like in Puppet. Each of our projects has a gem file that specifies the dependencies for development and testing, for Windows, as well as the specific versions of the gems that are needed.
All right, so let's talk about testing. This is a pretty major frustration for a lot of contributors as far as writing tests. It tends to be more difficult than actually writing code. So we want to talk a little bit about why tests matter. We don't want unexpected things to happen in the code, and tests help us ensure that that doesn't happen. So if functionality is tested, we can make sure that it's really working in the first place, and that later down the line there are no regressions, that something else doesn't break it, that everything is still working. So while tests may seem trivial and frustrating, they're pretty important for helping us maintain a quality code base, and we don't like explosions. So let's talk about running tests for starters. So all of our repositories will come with a spec directory. I believe this is Hailee, full of lots of unit tests that will help you make sure your code is working. So run tests early and often, run them when you get started, run them when you make changes. It's pretty quick. And especially if you only want to run for a specific file, you can specify the file you'd like to test. You can control the formatting of your tests. So we make it easy so that if something breaks, you can test early and know right away. And there's, like we said, there's lots of options. So if you're running tests in something like Puppet, where the whole suite takes like 6 or 8 minutes or something quite long, you can just run tests in files specific to what you're looking at. So you can see in these test outputs that everything's green, it all looks good, but sometimes it won't look like that. So you may see failing or pending tests. Pending tests will show up as little yellow stars, and there will be a warning that the test is pending. So tests that are pending have been specifically flagged that way, either because maybe someone can't figure out how to write the test or the functionality isn't there yet, but it's not meant to show up as a failure or something that's not working in the code. And you will also see failures, so the red F there. So Rspec will tell you what the failure was, what about the test was wrong and wasn't successful. It'll tell you which test example it was, and it'll tell you all the way down to the file and the line number. So it should be pretty easy to figure out where the error is coming from. And if you're getting sick of looking at dots and words, there's lots of fun things you can do to spice up your Rspec life. There's lots of fun formatters. Personal favorite is the Nyan Cat formatter. So all of your test examples appear as little rainbow dots behind the Nyan Cat. This is a gem you can download, and I believe there's a version with music, so have fun.
So writing tests is complicated. It's hard, especially when you start doing it. We can't really explain all of that in 3 slides, but we can give you kind of an example of how we're writing tests. So these are Rspec unit tests. We're testing individual units of code. So this can be, in this example, just one function. This is from factor.rb. It's just a function for warning. And the tests are correspondingly in spec unit factor spec.rb. So you can correlate which test file goes with which source code file. When writing unit tests, we have independent test cases. We want to test things in isolation. So we use mocks and stubs so that we don't actually have to rely on having data or actually having the program running. So in this example, we have an if statement with 3 different cases. And we go through those cases and test what would happen if we have those different options set. So to start with, we set debugging to true for factor. and we're going to call factor.warn with foo. And so we stub, you can see in this method calls kernel.warn, but we don't want that to actually run. So we're going to stub that method, and then we're going to say we expect that method to have run with this foo value. In another example, we would expect it to never have been called that warn method on the kernel. It should never have been called, even though debugging is true, because we have a nil message. So we just go through each of the kind of possibilities of the test. It only is calling the factor.warn method. It's never touching this kernel. And so this is how we kind of preserve the isolation. And we go through each of the possible cases that this method can cover. So that's kind of a pretty basic example. But as you can see from this, it's pretty easy to read what this test is doing. Tests should be readable. They should be understandable. You should be able to look at the test and understand from that what the method is actually doing. Do not do this. Do not do this. This is one block of tests that runs about, it runs about 1,200 tests. It's just each loops. It ends like this. Just don't do this. You can't understand what any of this is actually doing. It's just totally incomprehensible.
You'll notice we didn't even fit all the code on the slide.
It just goes off too. So please never do this.
Was that really submitted code, or?
This is in
Puppet.
So this is, if you look on GitHub, spec unit transaction resource harness spec.
I think it's our. Yeah.
Yeah, I think it's Paul
Barry?
someone
He
who
used to
used to
work
be a
there.
Puppet Labs employee. Yes. Adrian Thiebaud Finch on IRC is the one who showed this to us. And he said, you know, we would definitely welcome a refactor of this if anyone wants to take that on.
If you want this to be your first contribution,
go ahead.
I think this whole test example is over 300 lines, so you got your work cut out for you.
Yeah. 1,200 tests.
We actually had to like get out a pen and paper and multiply to figure out how many times.
Good.
So now that you're sufficiently horrified.
Yeah, don't do this.
Otherwise, your career will end.
So now that you've written your code and written some very nice looking tests, it's time to get the code ready to submit. So the general workflow in Git is you add changes, so you stage them for commit, you commit them, in which you write a message describing what you did, and then once all your commits are ready, you push to GitHub, and from there there's a pull request. So Git status is a really great way to see where you are in that process right now. Git status will show you what files are changed and what files are unstaged. So we can see here that we've modified the kernel spec, and it hasn't been staged for commit. And we also have added a new file that is also untracked. So if we were to make a commit right now, none of these things would get in there. So what you need to do is add them before you're ready to make your commit. So here they've been committed. We can see that staged things are up there in green. So the modification to the kernel spec is there. We're now tracking the new test file that's been added. So if we made a commit now, those things would be in there. However, we can see that there's another modification made to the new test file that hasn't been added, and that won't make it into our commit if we commit as is. So git diff is a slightly more kind of verbose version of git status. It shows you unstaged changes in code format as opposed to file names. So it'll show you things you've added in green, things you've deleted in red. So it makes it easy to figure out exactly what you're going to be staging. It also shows you your whitespace errors. So if you don't have whitespace highlighting in whatever text editor you're choosing to use, and you're like me, chances are you'll introduce a lot of whitespace errors into the code, and people will generally be unhappy about that. So this is a really quick and easy way to make sure that you don't make that mistake. So part of the idea of committing is to add your work in logical units. This is great for a lot of reasons. It's great for you because if you decide that you need to roll back, It's very easy to roll back one change. What you really don't want is like a change and a half in one commit and like 3/4 of a change in another commit, because that kind of defeats the purpose of committing as you go. It also makes it easier for us when we're reviewing your pull request, because every change will have a commit message associated with it, and it makes it much easier for anyone in the future who is trying to understand the changes that were made however long ago. So writing good commit messages is also something that's very essential for a lot of reasons. Again, it makes it very clear to anyone who's reviewing your code what happened in that change. It makes it easier for you to remember what happened. And it just makes everything, the whole process, go much faster. So the general format of a commit message is an imperative statement for the title, which includes your ticket number in front. So this should be a short-ish description of what exactly happened in this commit. Then you need a new line, and you'll move into the description of the commit. So the general idea with a commit description is that you want to write in the present tense usually. A good rule of thumb is to describe how the code was before your change, why that wasn't ideal and why your change was necessary, and how the code is now that the change has happened. So this is an example from our contributing.md doc, which is a great doc everyone should check out.
So it's awesome to commit as you go, but maybe you're writing a bunch of code and you don't want to write nice detailed commit messages. So I think I was really annoyed when I did this and put a lot of exclamation points and ones and stuff. And I don't actually want to push this up. I don't want to submit a pull request with these commits. So there's something that someone taught me, or that when I was taught, I was told it was magic, and it kind of is. Just git rebase-i. If you don't know about it, it's pretty awesome. You can use that to, here I'm just cleaning up those commits. I'm squashing my second commit, which was just a couple of white space errors. Doesn't need to be its own commit. It was a 3-character change. Squashing those two together, writing a better commit message, and I end up, it's much nicer, cleaned up. But I didn't have to worry about that when I was actually going and writing my code. So that's a nice trick to know.
OK. So now we're going to talk a little bit about the CLA. So we mentioned it before. The CLA is our contributor license agreement. This is basically something that you have to sign that will let us use your code in production. I've been told by Dawn that it's pretty lightweight as far as most CLA agreements go, and she told me that if you ever are in a situation where you're not sure about signing the CLA, definitely contact us, and we can figure out why you're uncomfortable and if we can do anything about it. So we will ask you to sign this before we can review and accept your code, unless, like we mentioned, we have implemented the trivial patch exemption. So if you make only a few lines of code change, it's not necessary for you to actually sign the CLA before we can accept your changes. So now we're going to submit a pull request. So basically, this is a way to say, OK, I've made my changes locally. I've tested them. I've added tests. I'm pretty sure that they're ready to go. And I'd like them to get merged into the Puppet Labs version of the source code. So what you need to do is go to GitHub. And if you click on Submit a Pull Request, you'll come up with an option like this. So you can select which branch you'd like to target and which branch you'd like to target from. So here I'm saying that I would like to target the Puppet Labs version of Factor, and I'd like to target the master branch, which is the branch that you'll be targeting probably like 95% of the time. The other option is the stable branch, which is generally accepted to be our next release of the software. So most of the time, we don't want changes to go in there unless for some reason it's fixing a regression or it's a very serious issue that's breaking a lot of things and it needs to go out right away. So when in doubt, target master. You're probably right. And then on the right, you can see that I'm choosing to target from my fork of Factor. And I've picked my topic branch that I made the change on. Once you select your branches, it will show you a diff of everything that you're asking to submit. In this case, I added a new line for fun. And this is a really good way to make sure that you're getting in the code you think you are and that your targeting is right. Because if your targeting is backwards, it'll be pretty immediately obvious when you see the diff for your pull request. So from that screen, once you submit a pull request, you'll be brought here. This is where you're going to give us the description of your pull request. So your title should also contain the ticket number as your commit message and as your topic branch have. And again, a short description of what you did. This is not an example of a good pull request description. What we'd really like to see is maybe a paragraph or two about what you did and why, what it's affecting, what changes you made. And if you do that, it makes it a lot easier for us to get started reviewing your code right away. If we frequently get pull requests with no title and no description, and then we just have a mysterious diff, and that's pretty hard to work with. So the more you can tell us, the easier it will probably be for us to review your code. And then when you're ready, you can just send in the pull request, and it will come to us. So what should you expect from us after you submit your pull request? A new feature that we've added is Travis CI. So Travis CI is a really handy thing that will tell us right away if you have made changes that have caused the test to fail. So basically what happens is as soon as your pull request is submitted, Travis will go out and run all of the Rspec tests with your changes, and then this will appear on your pull request. If all the tests pass and everything's A-OK, then you'll get this green one that tells us it's OK to merge it. If something fails, then you'll get the yellow one that says merge with caution. So if you see that, that's probably a good sign that you need to go back and reinvestigate something. Probably means that something's not quite right. Even though it's green, that might not mean that everything's right, but having a yellow one is definitely an obstacle that's going to be in your way. The next thing, as we talked about, is the CLA. So this has been very nicely automated. As soon as you submit a pull request, the Puppet CLA will come in and comment if the CLA has been signed by the contributors. And if it hasn't been signed by the contributors, it will also comment that. So those are two easy things you can knock out right away. Check if your Travis CI tests are passing, and check if you sign the CLA, because those are going to be both things that we'll ask you to look at if you haven't done that. So then, usually within a day or two, someone from Puppet Labs will come comment on your pull request. So on this particular pull request, I was asking the contributor if they could add tests. That's something you will hear commonly. I gave a short description of what I was looking for and gave them an example to look at. And then we just wait and see what kind of response we get. So this is more conversation from the same pull request. We will check in with you if we feel like we haven't heard from you in a week or two, because we like to not let pull requests sit. So here Adrian checks in with the contributor. The contributor says he couldn't figure out how to write the test. At this stage, what we would really like to do is get on IRC with you or something and help you figure out how to write the tests. But if not, there's other ways you can help us out. So what Adrian needed was some fixture data to figure out what the test should look like. The contributor was able to provide that, and then Adrian was able to write the tests and get the pull requests merged. So expect a lot of back and forth. Chances are things won't be perfect the first time, and we'll try to be as helpful and respond as quickly as we can. And another thing we'd encourage everyone to keep in mind is that pull requests are cheap. If you can't get to your code in a couple weeks, if we asked you a couple times and haven't gotten a response, there's a pretty good chance that we'll close your pull request just to keep our backlog reasonable, but that doesn't mean that it's not a valuable contribution. It just means that you should reopen the pull request when you have more time to work on it with us. So chances are that you won't know everything right away, and that you'll need to ask some questions. And there are a lot of resources to do that. So we have the new Ask site. That's a great place to post questions or look for previous questions or give answers if you're interested. We also have the IRC channels. So Puppet Dev is devoted totally to development. That's a really good place to go if you need help with Rspec tests or something like that. That's going to get you a pretty immediate response. I think there's people on there almost 24/7. If you're not looking for a speedy response, but you would prefer for your question to be seen by a lot of people, then the Google mailing lists are a really good choice. There is Puppet users and Puppet Dev, so then your question will go out to everyone on that mailing list. If any of you are on those, you probably see the big long, like 12 or 15 email threads talking about stuff, so that's a great place to get your question seen by a lot of people.
You should note with that, Puppet Dev is generally about development on the Puppet core projects. If you're looking for help on modules or anything about implementing Puppet, you want to go to Puppet users. So obviously, we've talked about Git, Rspec, Ruby, our own contribution process. And this is 30, 40 minutes. We don't have time to really go into depth on that. We've put together a gist with links to a bunch of resources for all of those things. be reached at that short link. And please, comment if you've got other resources that have helped you or, can think of anything. Yeah. Any questions? Yeah?
What kind of test coverage are you looking for?
So I think in the example that Hailee had, it was kind of adding a new fact for an operating system. And then it's, we want to make sure that you will get the proper output for the fact given the right input. For other, it depends on the extent of the change. Obviously, bigger changes are going to require more test coverage.
Yeah, a good way to think about test coverage is to think about the kind of situations that the change could be in. So in that case, we were looking at a method that will change based off of whether something is set to nil. So you can think about what if it's nil, what if it's not nil, what if you're in this situation, and just make sure that it behaves properly in that context. We also have stuff like acceptance tests, but
Yeah.
we mostly expect unit tests from contributors.
Yes, just to add to that, we do have an acceptance suite that will run after pull requests are merged in. If you ever are interested in looking into that, we use the Puppet acceptance, which is a GitHub repo for running and launching all of our tests. But gets definitely more complicated. We don't expect for all of our contributors to write detailed acceptance tests. We are just looking for unit tests.
And you can also see our acceptance tests publicly on Jenkins.
Jenkins.delivery.puppetlabs.net, I believe. You can see all of our tests. Yeah.
You might have already answered it, but does every single line of code get eyeball review by Puppet?
For the most part, I would say yes. I think there's probably a couple situations if it's like a very, very big change where we can't look at every single line of code. But chances are, yes, we will look at everything that's been added, so,
Yeah.
or deleted. Okay.
Yeah, so I'm one of the engineers, there we go, great, that was responsible for merging in a lot of the changes that Aaron Stone had done for the open source dashboard. And I hand reviewed all like 16,000 lines of code that was changed.
Yeah.
So, yeah.
Yeah.
There are
So-
eyeballs on everything.
Yes, yeah, you will have someone looking at everything, and Jeff did an amazing job with that.
Yeah.
Is there a standard answer for knowing whether a standard library, whether if you want to make a contribution to a standard library, whether you should work off the standard library or make a new module expanding on it?
We don't.
Yeah, I think
I
it
think
probably depends.
I think someone on the Forge team or someone who's working on modules would know better than us.
Yeah, but that's definitely something to, if you do encounter
Is there a
that.
good place to ask that?
Yeah,
Yeah.
Puppet Dev on IRC, pound Puppet Dev, or Puppet Dev on Google Groups. And I think we've got Hunter Hagen and Ashley Penny who have been working on modules. So I think that's Ash P on IRC and Hunter on IRC, and they're probably the two best people to ask about that. Yeah. You had a question.
Well, I just wanted to point out something. I've been having a hard time testing native types and providers.
Yeah.
There's not a lot of documentation around it, but Josh Cooper pointed me out to a new gem called Puppet Labs Spec Helper,
Oh yeah.
Yeah.
which just worth mentioning.
Mhm.
It's probably not in any documentation anywhere.
Yeah, I
Right.
think it's
in the gem
pulled
file.
in the gem file for Puppet, but yeah, that's a good point, and I think that's something that's good to look at if you need more information on stuff like types and providers, which are definitely pretty tricky. Yeah. Anyone else? All right. Cool. Thank you.